All right, so in this first example, our goal is to graph 3 to the x power. The function f of x equals 3 to the x power. And if we just connect some dots to start things off, I see that my base b is larger than 1. I don't see any negatives. So we should be expecting a exponential growth graph here. The way I want you to graph this is pretty straightforward. I want you to just make a t-chart. On the left side, I'm going to list my x values. On the right side, my y values. And for any exponential function, I want you to start thinking of these functions as being another mother function. And so for each of these, your key points are always going to be the whatever points have the x coordinates -2, -1, 0, +1, and 2. And so one thing I do want to be clear about is that for every different exponential function, for every different base, you will have to find new key points for your mother function, and you'll just do that by taking your x coordinate and plugging it in for x and evaluating to find the output, or y coordinate. So if we start with the simpler ones, when I look at where x is 0, I take 0, I plug it into x, so I've got 3 to the 0 power, and any base to the 0 power is going to give us 1. So there's the first point for the graph of 3 to the x. So I'm going to plot that point right here at 0, 1. Good. If I put 1 in for x, I have 3 to the first power, which is 3. There's my second point, 1, 3. Over 1, up 3. And my third point, if I put 2 in for x, I have 3 to the second power, which is 9. So my third point is 2, 9. I go over 2, up 9. There's my third point. I need to find 2 more points. And let's remember here that if I do 3 to the -2 power, which I get by taking -2 and plugging it in for x, remember that that's the same as 1 over 3 to the +2 power, which equals 1/9. And if I do 3 to the -1st power, that's the same as 1 over 3 to the +1st power, which is just 1/3. So there's my remaining 2 points. I've got the point -1, 1/3. So I'm going to estimate and go about 1/3 of the way up above the x-axis. And then I've got the point -2, 1/9. Here I'm really just trying to get a point that has an x-coordinate of -2 and is right above the x-axis. If we look at this graph, we can see that we have an asymptote here, a horizontal asymptote, and in this case that asymptote is the x-axis. So let's just label that asymptote is y equals 0. And then I'm just going to finish this off by connecting the dots, showing that on the left it approaches that asymptote, and that on the right it goes to +infinity. That's the end of example 1. We were just graphing the graph of 3 to the x power. Take your time to copy this down. If you need to pause the video here, you can, before we move on to look at our 4 rules for transforming exponential functions. So now we're looking at the 4 different ways we can transform an exponential function. And this chart should look very similar to what we did last semester when we were transforming functions such as the graph of x squared, the graph of the square root of x. We're going to be repeating that same basic method today with exponential functions. And these first two are transformations that we worked with on Thursday and Friday in that Desmos activity. Whenever we have a negative in front of an exponential function, and last semester we referred to this as negative. Let me just correct my... Alright, we refer to it as negative f of x. Whenever you have a negative in front of this, you're going to have a reflection over the x-axis. And remember, it's really important to remember what a reflection over the x-axis is going to be in terms of the way the function's moving. This is going to be a vertical reflection, right? Our second transformation occurs when we have a negative in the exponent. The way we wrote this last semester was if we had f of negative x. And in this case, this is also going to be a reflection, but it's going to be a reflection over the other axis, a reflection over the y-axis. And remember, even though it's the y-axis, if we think about a single point and reflect it over the y-axis, that single point is going to move horizontally. It's going to move horizontally. And then the same is going to be true of our function. If we start with an exponential function and reflect it over the y-axis, it's going to move or be reflected horizontally. There's two more transformations here, and we didn't work with either of these on Thursday or Friday, but you should be very familiar with them. If we add c units to the end, and let's look at an example of this. An example of this might be if we had 3 to the x plus 2. If we have a plus 2 at the end, this is going to be a shift up or down c units. And so for this example, it would go up 2 units. I'll give you a few seconds to write that down. Make sure you're writing all of this down. And that leaves our fourth and final transformation, where we have a certain number being added actually in the exponent. So an example of this would be something like 3, and in the exponent, let's say we're adding 4. 3 to the x plus 4, where x and the 4 are all in the exponent. And this is going to be a shift left or right. And I'm going to write this as negative d units. The reason I wrote the negative there is because recall that when we add a number to the x inside the function, it moves in the opposite direction. And so for this example, if I have 3 to the x plus 4, that plus 4 is actually going to move my entire function to the left. That's in a negative direction, to the left 4 units. So we're going to do an example with this in a bit, but for now make sure you have all of this written down. And again, you can pause the video here if necessary. So now we're looking at our next example. And this is the first place where we're going to actually use a mother function to shift and graph an exponential function. So let's just start by looking at this equation, which is negative 3 to the x plus 3 minus 4. And let's start just by identifying what exactly our reflections and shifts are. I look at this, I remember that I need to always list my left or right shift first. And I see a plus 3 in the exponent, so that is going to be a shift 3 to the left. I'm going to be going left 3. I then look for my reflections. I see I have a negative in front. And so that means I'm going to be having a reflection over the x-axis. Which, remember, is going to be a vertical reflection. And last but not least, I look for any shifts up or down. I see a minus 4, which means I'm going to go down 4 units. Now this information is only going to be helpful once I have an idea of the mother function I'm actually working with. And so while the mother function for this problem is the same as the one we did at the beginning of these notes, I'm going to walk you through kind of the way I want you to organize your work. So we're going to make a chart, and the chart's going to have 3 columns. On the leftmost column, I'm just going to list those 5 x values I'm always going to use for an exponential function. Negative 2, negative 1, 0, 1, and 2. In the next column, I'm going to write mf for mother function, and I'm going to list what that mother function is. My mother function in this case is 3 to the x power. And it's in this column that I'm going to actually list what the key points are. And so I know that all the x coordinates of my key points, it's going to be the same as in that first column. And I'm going to find the y coordinates of these key points by repeating the process I did in the first example. I'm going to do negative 2 to the x power. I'm just looking at this mother function, which is going to give me 1/9. Negative 1, so 3 to the negative 1 is going to give me 1/3. 0, 3 to the 0 power is going to give me 1. When x is 1, 3 to the first power is going to give me 3, and 3 to the second power will give me 9. So these 5 points are going to be my key points for this mother function. And it's in this last column that I'm going to come up with the equation I'm going to use to move these key points so that they're now at the graph of negative 3 to the x plus 3 minus 4, so that they include these 3 transformations. So I'm going to write an x and a y. Left 3, I know that's going to affect my x coordinate, so I've got x minus 3. A reflection over the x-axis, that's vertical, so that's going to affect my y, so I'm going to put a negative in front of the y. And finally, my whole function needs to go down 4. So I'm going to subtract 4 from y. And that gives me the function that we'll use to move these key points. I'm going to end this video, and we're going to move on to our third part of the video. I can only take videos in 15-minute chunks, so we'll pick up right where we left off shortly.